Okay, thank you. Can we change derived column data type? Yeah, we have a data conversion. Huh? That day I have shown you data conversion in a conditional speed transformation. So I have shown you how to change the data type of a column. We can go to here. See, this is a data conversion. Data conversion is the data type conversion. Okay. Now, so yesterday we were discussing about multiple sources. Okay, what is that? Multiple sources. So what if the situation if we have multiple sources at a time? Okay, so I mean more than two sources. Okay, so we have discussed to get the data using union all transformation. But what is the problem with the union all transformation? The problem with the union all transformation will not allow the data into a proper order. Okay, so you will not get any proper order in the destination data, right? Okay, now you can see, in order to show you that, I'm going to add another two tables. See, total how many number of tables? Total four tables. Okay, so what is the transformation that we are using here? Union all. Okay, so what are the preconditions? Okay, what are the preconditions that we need to have for the union all transformation? See, like a merge transformation, the type of sources should be same. Okay, the type of sources should be same and the structure of the sources should be same. Okay, these are the two important preconditions for the union all operation. Okay, so for other operations, I mean for other operation means, so what about the merge operation? It is not, sorry, sort operation, it is not that much required. Okay, so union all transformation is having a capability to get the data from two sources or more than two sources, but at the end of the day it will not give you any guarantee for the sorting of the data. Okay, sorting of the data. Now in this particular situation, so what I'm trying to tell you is, if the data is not available, okay, if the data is available, not available in a sorted order, even though we can combine the data, I mean we can get the data from that source using union all transformation. So union all transformation will just collect the data from multiple sources. That's it. Okay, we'll just collect the data from multiple sources. Okay, and it is not responsible for the data sort operations. Okay, so even though if you use the sort transformation, it will not load the data in the sorted order to the destination, okay, directly, but indirectly there is another shortcut. I will show you a small logic we need to implement. Okay, if you can implement that one, the data will become in a sorted order. Okay, so first of all I will show you how you can use the union all transformation in order to collect the data from multiple sources. Okay, that is the reason I have created four tables totally. Okay, Table. Okay. So change the name of table B. Okay. Table CC. Okay. So name to CC. Man. Table reading. Table reading. Okay. So total how many tables? 4 tables. Okay. Let us combine the data. Okay. And then see, if you feel these connects are not, I mean, the connecting process to the union all transformation is not properly, just what you can do, so this alignment is not good, then select this component, just shake once, okay, just shake once, automatically order, it will arrange the order, okay, so properly. You don't need to do anything. So finally, then go to OLED destination. Okay, and then open this. Okay, same database, go to this one and union all destination. Okay, okay, go to mappings. Okay, execute. So three rows, all 3 rows, and then total 12 rows. Okay, so as per the count, 12 rows is correct. Okay, not a problem. But look at that destination. How many rows? 12 rows. Okay, so can you see the data in a proper order? No. Why? Because it has combined by the union all operation. Okay, so union all won't give you any guarantee for the data combining operations. Okay, I mean data sorting order. Okay, now let us execute here. Truncate table union destination. Okay, why? Because I'm going to show you along with the sort operation. Okay, so initially I didn't get any sorting data in the destination, so I want to sort the data using sort operation, and then I will try how the data will be loaded. Select employee number. Okay, Okay, now you can combine the data. So what you have done here, you have additionally added sort operation to the package. So for what purpose? You thought if you add the sort operation, maybe the data will properly sorted and then it will load into the destination. Okay, so but let us see how it will behave. Okay, now so do we have any data in the destination table? Nothing. Okay, now you can execute here. Okay, total 12 rows once again. Go to this and go to union destination. You can say. So even though if you use a sorted transformation, the data was not in a sorted order. Okay, that is what the union all transformation. That is what union all transformation. Union all transformation will mainly use it to combine the data from multiple tables. Okay, but it will never give you any guarantee for the sort operation. Even though if you sort the data and give it to union all, nothing will happen. The data will never be sorted. Okay, so by using a union all operation, so we can get the data in a sorted order by following one shortcut here. Okay, so one simple logic. So what we can do is, so we can sort the data after union all, not before union all. Okay, so here let us remove all these components not required. Okay, directly combine the data. Open this. That's it. Okay, so union all, sort, and OLED destination. Simple. Okay, now let me truncate the table over there and I will show you how this output will comes into the picture. Let us execute. Okay, 12 rows. Now execute. Now you can see. Okay, so union all, what it is doing actually, if you apply the sort operation, first of all data will be sorted, combined, and then data will be sorted and combined, and then data will be sorted and combined, and then data will be sorted and combined at the fourth table. But finally it will not combining the data, it will not sorting the data in the whole table. Okay, so that is the reason individual sort we don't need here. In this case we need the whole data needs to be sorted. That is the reason I have used the sorted transformation with the union all. Okay, so this is what the approach what we need to understand about this union all transformation. Okay, so by using this union all you can get the data from multiple places. So but if you want to get the data in a sorted order, you can just use a sort operation after union all. Don't ever use union sort operation before union all. It will not make any change. Okay, so that is what. Understand or any doubts? Okay, so yesterday me and Fred was discussing one point. What is that? So I have asked one question. For that Fred has given the answer S. What is that question? Merge transformation can allow more than two sources. Okay, he said S. Okay, that is indirectly that is correct answer. Okay, so directly it is not correct answer, but indirectly it is correct answer. Okay, so I will tell you the reason. What is this? Source 1, source 2, source 3, source 4. Okay, so you have a 4 sources in your hand. Okay, so you must load the data by using, merge transformation only, not any other transformation. Okay, understand my point? So you should not load the data by using any other transformation. Okay, you should load the data by using merge transformation, not union all. Okay, so in this case, how you will get the data from these 4 sources at a time, and how you will combine the data, how you load the data into the destination? That is what my question. Okay, so here what we can do, so understand very carefully, it is a little bit lengthy process. Sort 1, okay, sort 2, okay, merge 1, okay, merge 2, okay, and then again and then destination. Okay, now just to load, okay, here understand very carefully, just to load the data from 4 sources, 1 2 3 4 sources. See how many sort operations you have used and how many merge operations you have used. 1 2 3 4 5 6. So total 6 sort operation. Merge 1 2 3, okay, merge total 3. Okay, how many? Total 9. Okay, suppose in this particular approach, so in order to get the same data, from same number of sources, so how many transformations we have used? One union all, one sort. Okay, so you can imagine, so one union all, one sort. Total how many? 2. So imagine how much complex it is, okay, and how much risk it is. Okay, see, merge transformation will be good whenever the data you want in a sorted order. Okay, but it will be applicable only for 2 sources. If you want to apply for more than 2 sources, see, this approach we need to follow. Okay, it doesn't mean that it will not accept more than 2 sources. It will accept, but not directly. Indirectly it will accept. Okay, so this is what we need to understand, the merge transformation when we are having a more than 2 sources. For 2 sources, okay, even that also 2 sorts, one merge operation. Okay, but still we can accept this one. Okay, more than 2 it will become a problem. Okay, so this is what we need to understand, the union all transformation. Any doubts? Union all and merge on these things? Anybody? Fred, is clear to you now? Oh, okay. Yeah, please tell me.
Can you explain again once?
Which one? This one? This one?
Yeah.
Actually, you know that merge transformation will accept only the data from two sources, right? So here, first of all, divide the total components into two sets. Okay, so source 1 and source 2. Okay, so in order to combine the data from these two sources, I have used the merge transformation. Okay, Ashok. So sort 1 and sort 2. Okay, again sort 3, so source 3 and source 4. These are two different sources. Sort 3 and sort 4 again merge 2. Okay, so next time we have combined the data into two merge transformations. Then what we need to do, so for the package, this merge and this merge will become two sources. Okay, so again we need to consider indirectly this as the source 1 and this as the source 2. That is the reason I have used the sort once again. I have used sort once again. Okay, sort 4, sort 5 and sort 6. Now the data will be then loaded. Understand, Ashok?
Okay.
Okay.
Narendra,
Yeah, please.
in union we are using sort after union. Can we use here in the merge also after merging the data copy?
After
Merge.
After merge transformation, you want to use union all.
Sort. Before only we have to use, or after also we can use?
Oh, after merge you can use sort. That is what your question. Yeah, we can use.
In union all, in union all we have used the sort operation.
Okay.
After union all operation, union all this one. Same thing can we do here? Because here we are using sort 2 times.
Yeah, sort 2 times.
Sort 1 and sort 2.
Yeah, sort 5.
Same thing. From source 1, source 2, we have to first we have, can we do merge and then sort?
1 minute. Actually, I didn't get the question properly.
Yes. Source 1, source 2 are there, no? From source 1 you are sorting. So again from source 2 you are sorting. Then you are merging.
Yes, correct.
What I am telling you, from source 1, source 2, directly can we merge and then sort?
That is what the problem. See, in order to perform the merge transformation, so without sort it will not allow you to do that. Yesterday I have shown you now, without sort operation I have tried to merge, but what is that error? So that input source 1 and input source 2 so doesn't have any sort property. Okay, that means what? Without sorting property on the two sources, merge transformation will not accept the data.
So it is a mandatory to
sort. Exactly. It is mandatory. Okay. So Fred, you are asking one question. I think this is what he is asking. What will happen if you sort the data after merge instead of before? Yes. Okay, I clarified his question. So what is your question, Fred? You said you have one question. What will happen if you sort the data after merge instead of before? No, it will not allow you to do that. That is what. We can do that, but it will not allow us. So that is the same problem we got yesterday when we are trying to get the data from two sources at a time. So do we have to use sorts after merge 1 and 2 as the results are already sorted? Yes. Again, why? Because here you need to understand one point. Wherever you are using a merge transformation will allows the data after sorting only. Okay, so here it is combined. Here it is combined. That means what? Let us say, for example, I will show you one scenario. So 1, 2, 3. Okay, 4, 5, 6. Okay, so now 7, 8, 9. Okay, 10, 11, 12. Okay, so this data will become 1 to 6 here, and this data will become 7 to 12 here. If you don't sort the data, what will happen? So 1 will come, then 3 will come, then 7 will come, like that. Okay, so if you sort the data properly, first of all, one set of the data will be loaded, and then whenever it is trying to load the data from the second set, it will properly arrange the data and then combine the data for that only. So even though if you have used sort transformation here, but still we need to use the sort transformation once again if you are using the merge. Understand, Sharin? Okay, so this is what we need to understand union transformation, merge and union all. Okay, so instead of this lengthy approach, so you can directly go for the union all operation, not a problem. But
Narendra,
hello, yeah.
Narendra, I didn't actually get it. Like you said, after merge 1, the data will be like, it will come from 1 to 6, right? And merge 2, it will be in order, right, from 7 to 12. So, so the data after merge 3 will come in order, right? It will first takes those 1 to 6, and then only it will load the 7 to 12, even without the sorts.
Yeah,
right?
actually, if you don't use the merge, if you don't use the sort transformation after 2 merges, see, it may load the data from the source 2, or it may load the data from the source 1. Okay, so we cannot estimate.
Okay.
We cannot estimate.
Yeah, maybe
Yeah,
it can be from 7 to 12 and then 1 to 6.
yes, correct.
Okay.
And that too, this is one of the very important scenario. If you see the tables, the data is in proper order. See, 1, 3, 5, 2, 4, 6. So if you combine the data, see, 1 to 6 will be available in one set, and 7 to 12 will be available in another set. If it will by mistakenly, if it will load 7 to 12 first and then 1 to 6 next, what is the meaning? There is no proper meaning, right, in the data. That is the reason.
Okay. Thank you.
Yep. So the next concept what we are going to discuss is merge join. Okay, so the concept is called what? Merge join. What do you mean by merge join transformation? See, merge join transformation is mainly useful to collect and combine, combine and collect the data from two different sources. Okay, so merge transformation we have seen. So to combine and then collect the data from the two identical sources. Okay, two same source tables. Okay, but with the merge join transformation, so you can combine and collect the data from two different sources. Two different sources means two different source tables. Okay, so type of sources should be same always. Okay, so if the table 1 is having a one type of structure, if the table 2 is having a another type of structure. Okay, but still we can merge the data from the two tables. Okay, so while we are merging the data, we are using additional operation. What is that? Join, merge join. That is nothing but what? After combining the data, we are retrieving only matching information. Okay, so if you want to perform this type of operations, okay, if you want to perform this type of operations, you can use the merge join. Okay, for the merge join, the type of sources should be same, that is for sure. That structure of the sources may be same or may not be same. Okay, it is not a mandatory that structure of the two sources should be same. Okay, so that is what we need to understand. And anyway, sort definitely will be there if you see the word called merge. Okay, so this is how the total architecture and preconditions are available. Okay, so merge is different. Merge is useful in order to collect the data from two same structure sources. Okay, but merge join transformation will allows you to get the data from two different structure related sources. Okay, now in this situation, so how you can get the data from two different structure sources because of the join operation. Okay, so merge will be used to combine the table, join will be used to retrieve the matching data from the table. Okay, that is the reason merge operation plus join operation will makes merge join transformation. Okay, so the best example what I can give you is this table. Okay, so as you can see in this table, so I want to retrieve some of employee information and some his department information. So for that, what I can do, select e.ename, e.job, e.salary, DPT number, dname, d.location from emp as e, inner join dept as d. Okay, on d.dept number. e.dept number. Okay, if you look at the code now, see, look at this code. Just give me 1 minute, I will come back. Now you can see how many rows are there matching. 14 rows are there. Okay, so before combining the table, please look into the structure. How many columns are there in the department table? 4 columns. And how many columns are there in the employee table? 8 columns. Okay, so this structure wise, these two tables are same? Not same. Okay, but still we can able to get the data from these two sources. Okay, so whenever you are trying to get the data from these types of sources, you can use the merge join transformation. Okay, so what is that merge join? source table DEPT. Okay, and source table EMP. Okay, open this and select the table called EMP. Okay, go to columns, verify all the columns are coming or not. Okay, and then what is the important operation? Sort operation. Okay, so for this, do we need to sort the data? Yes, that is for good also. Okay, why? Because if the data is in a sorted order, matching can be done very easily. Okay. Okay, now you can see. So we have combined these two sources to the merge join transformation. Double click, you can see. So merge join transformation editor. Okay, now you can see. Configure the properties used to join two sources of sorted data, not unsorted data. Select the join type and they specify the columns to be used. The join key. Join keys must be used in the order specified by the sort key positions of the column. Okay. So what is the join key? Join key is nothing but what? Based on what columns we are matching the data. Okay. So from the DEPT table, what is the column? Department number. From the employee table, what is the column? Department number. Okay. So from the both the tables, so we are having a matching column called department number. Okay. Now, what type of join you want to use? Inner join, left outer join, full outer join. So why not right outer join here? See, it will be very simple to understand. So if you just change the positions of the table, right outer will become left outer will become right outer. Okay. So that is the reason there is no specific right outer here. Okay. So left outer and full outer join. So which type of join you want to use here? So I can use inner join. Okay. As I used earlier. Okay. So what are the information that you want to do, that you want to take to the destination? So employee number, employee name. See, once I'm selecting, that columns are coming here. Salary. Okay. And department number, department name, location. Okay. Now, open this. Okay. So new. Okay. Execute. Okay. So total how many rows? 4 rows, 17 rows. So actually if you use the merge join, 4 plus 7, 17 what? 21. But here we are getting only 14 rows. Why? Because only these 14 rows having the matching data. Okay. Merge join destination. You can see the data. Now I will show you the two data sets at a time. See, what is the difference between this data set and this data set? Have you observed? The data in the first data set is not in a sorted order, and the data set in the second data set, the data in the second data set is in a sorted order. Why? Because so this particular table was populated by the merge join transformation, and that too we have used a sorted transformation. Okay, so but here I have just blindly written. So if you want to see the data same way with the which compared to, like, that one, so order by 5. Okay, now you can see there won't be any difference here. Accounting, what is the first person? This one. Okay, 77782. Okay, see this one, same 10th department data and 20th department data, and here also 20th department data and 30th department data. Okay, so that is how we can use this particular data. We can use this particular merge join transformation in order to combine the data with a sorted order property. Okay, so if the data is sorted, it will be more useful for the sorting operation also. Okay, so that is what we need to understand. Okay, so we have seen, I mean, from the multiple sources we have seen merge transformation, union all transformation, and merge join transformation also. Okay, merge transformation will be useful for the sources which are having the same structure. Merge join transformation will be useful for the sources which doesn't have the same structure. Okay, now, so with this, actually there are two types of transformations in SSIS. Okay, what are the two types of transformations? Synchronous transformations, asynchronous transformations. So what you mean by synchronous transformation and what you mean by asynchronous transformation? See, it is very simple to understand. Synchronous is nothing but what? Synchronous transformation is, so it will be part of ETL process and it will be cause for the data changing process. Okay, so which transformation will change the data? Which transformations will change the data? Those transformations called synchronous transformations. Okay, so which transformations will not change the data? Those transformations we can call asynchronous transformations. Okay, so in as of now, whatever we have seen, okay, so character map we have seen, aggregate we have seen, conditional split, derived column, merge transformation, union all transformation, so merge join transformations. So all these transformations have changed the data format from one format to another format. Okay, so these transformations are called synchronous transformations. So as of now, we have not seen any transformation which is asynchronous. Okay, so there are 4 types of transformations to be named. Okay, one is row count, another one is row sampling, third one is row count and audit transformation, row sampling transformations, and percentage sampling transformations. Okay, so these are the 4 transformations which are mainly important in the asynchronous transformation, out of which row count transformation is very important. I'm telling you. Okay, row count transformation is very important. So without that, okay, so 99%, I mean, there are 90%, all the packages will have the row count transformation. That is called asynchronous transformation. Okay, it is bit lengthy transformation and I want to explain it tomorrow. Okay, so if you have any doubts, I will explain today. As of now, whatever the transformation that we have discussed, so if you guys having any doubts, okay, I'm ready to explain today. Okay, tomorrow I'm going to start asynchronous transformation. I will try to complete in one session, otherwise I need another one session. Okay, total 2 sessions to complete asynchronous, and after that there are very important transformations, pivot and lookup. Okay, important in the sense not as per the usage purpose. Okay, as per the conceptual purpose, those two are very important. Even though we are using or not using, it doesn't matter, but those two will be a powerful transformations in SSIS. Okay, so as of now, any doubts to anybody? Okay, I can tell you small transformation, but my throat is not supporting. Again, I need to take another 3 sessions continuously. That's the reason. Okay, anyway.